The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, July 20th, 2023. We're back into our regular setup here, Dane. How are you doing today, man?
Doing pretty good, you know, got through the storm and everything all right. Besides it being pretty hot out here, doing pretty good, you know.
Yeah, for sure. Yeah, so we did have Tropical Storm Calvin just skirt the island here. No major impacts, but of course it does produce some interesting signals in the volcanoes as well as causing us to scurry about and get ready for any potential impact. So we'll talk about the what's happening in the volcanoes, both Kilauea and Mauna Loa, not erupting, quiet at the surface, both inflating fairly quietly, not a lot of earthquakes. But Kilauea is showing a little bit more life there as far as its uplift in GPS. So we'll cover that today. We'll talk about some of the comparisons of this most recent eruption to the previous summit eruptions we've had since 2018, and maybe go into a little bit more on Mauna Loa, just a tiny bit of what we can share with you guys, and I'll do that in a summary here as well. Is there anything you want to throw in before we get going on that, Dane?
No, I think you covered it well there. We'll get into it. If anybody has any comments, questions, throw them in the chat, and we'll see if we can get to them at the end.
Sounds good. So let's transition here and put up for you guys Hawaiian Volcano summary. Let me just see if I can fix this. That looks it's just on the screen a little too much there. So, all right. There we go. All right. So this week's Hawaiian Volcano Summary. This is a live looking at Kilauea on the USGS live camera. And what you see is a quietly degassing volcano. A little bit of steam, but really not that much. There was a little bit of rainfall on Kilauea as a result of Tropical Storm Calvin that just went by that left some interesting short-term signals on the volcano, but we're not concerned with those as much. More so that the volcano is still quiet on its surface. Here it is panning around. You can see the full caldera there. And if we go to the monitoring signals, I thought I'd show you guys today just this GPS distance between the north and south of Kilauea caldera. And what this is showing for you guys is that this line length here on the right is still going up right there. Last week it was a little bit flatter, but it seems like it's resumed its previous trend, and this is basically showing that the north and south side of Kilauea caldera are still getting further and further apart. Not only that, they're also both rising, so that suggests that the volcano is still swelling from below. The main effect on the volcano is still magma building up underground, with no effect of the storm passing overhead here. So that's really the long-term story for Kilauea. There's not much else to share today other than this long-term pattern on that in our summary. We'll switch over to Mauna Loa, which also has similar signals, but I thought today I'd just focus on the one signal of Pakuhanalei, which is up about 12,000 feet elevation, looking at the vertical signal, the up signal here. And what you see here is this drop down from the eruption, and it drops down to around this level right here by this dotted line, and it's risen up in the last, how long has it been, 7 months, up to around here. So this difference is about 5 centimeters or 2 inches. This goes to show what this recharge process on Mauna Loa actually looks like. The volcano is still swelling, not a lot of earthquakes, not really building up a whole lot, but it is refilling and inhaling, so to speak, and inflating its flanks there. So you can see that the signal was a little bit steeper at first, maybe slightly slower, and then maybe slightly slower again. So it does seem to be still rising, but at a slower and slower rate. And that just shows that Kilauea and Mauna Loa are both filling in on Hawaii Island today. So that's the Hawaiian Volcano Summary for this week. And we'll go into more detail here by first looking at Tropical Storm Calvin here. And so I'll play you guys a satellite animation while I get things switched over here. This is just showing the GOES 18 signal, showing the storm. It comes in from the east there and hits that southerly wind shear, and the top gets blown off, and it kind of breaks apart there before actually coming onto the island, although there are certainly some rain and wind impacts. Pretty localized, but actually then spreading across the island chain you see there. So just to preempt any kind of question, we've talked about the weather affecting volcanoes in the past. This is a pretty clear non-affecting situation here, but I thought it would be a good way for us to start just talking about things as we move through the signals here, because we are going to see some of the signals. And the first thing we'll talk about is actually volcanic hazards. So that's always a gas being emitted from the volcano. Before I get to that, let me just first show this rainfall graph from Hawaii Volcanoes National Park. So this is for the last week here. So we're really showing from 5 p.m. on, what night was that, Dane? Monday night? No, Tuesday night, 5 p.m. on Tuesday night until 5 a.m. on Wednesday morning. And there is when the bulk of that rainfall actually fell. About 3 inches in total at a maximum rate of 0.4 inches per hour in the national park. So besides this low emissions of gas, we also have all the rain coming to potentially clear out the air and the winds to blow things around as well. So all that said, we can then turn to our VMAP forecast from University of Hawaii. This is the VOG mapping project. And here you can see the emission source is Kilauea, and it's such a low source. It's actually showing 104 tons per day as the output. So you only see a very brief patch of light orange right in there in a downwind area towards Pahala and Ka'u area there. Otherwise, it's looking pretty good as far as VOG. We know that even these low emissions from Kilauea that we're seeing now are exceeding industrial standards, and so can certainly have big effects on the nearby residents, especially if they have sensitivities. But this seems to be a good week coming up here because of this storm that came through. So it did have a good effect in that sense there. Along those lines, I can show you guys, this is the Purple Air Citizen Science page, and everything in the green across the island everywhere, which sometimes we even see some other abnormally high data points for that are not volcanically related. Everything seems to be cleared out and fairly low today. So that is the hazard summary. Not a whole lot of hazard out there because of that. which we can be thankful for. So we'll go into our monitoring for Kilauea to start here. And we'll do that by first touching on our official source, the USGS Hawaiian Volcano Observatory. Here's their weekly update put out on Tuesday, July 18th, a couple days ago. And nothing really groundbreaking in here. We're still at aviation code yellow, alert level advisory. Volcano is not erupting. The eruption paused on June 19th. Lava no longer flowing on the crater floor, and no significant changes at the summit or in either rift zone over the past week. They note an SO2 measurement rate of 104 tons per day on July 17th on Monday, and no active lava observed over the past 3 weeks. Otherwise, East Rift Zone, no unusual activity along the East Rift Zone or Southwest Rift Zone. Steady rates of ground formation and seismicity continue along both. They also note very little gas coming out from the Rift Zone as noted by their instruments here. Hazard analysis is mostly the same, mostly the gases here. Instability, rock falls, and all that are still possible near the caldera, all in a closed area, so really don't have to worry about that, and especially here over the video. So pretty standard here, not a lot of insight that we can get from this update, just telling us all is calm and well here, essentially. So we can go into a little more detail and pull up some of the graphs, and let's start here by looking at our tilt. At the top we have the last 2 days, and I wanted to show this one because it actually shows the time frame a little bit better. So this is for the last 2 days, so this goes back to Tuesday night. So here is the onset, somewhere around here, 5 p.m. or so, somewhere in there, where the rain starts accumulating, and it ends around 5 a.m., somewhere in here or so, right? So you can pretty much presume that this extra steep rise right in here is somewhat rain-induced. If I zoom it back out, you can see that actually it's then seems to sag back down, and maybe by morning today, it starts coming back up on an upward trend once again. Overall, the net the last 2 days, you can see from down here to up here, it's still positive. It's still net upwards, but maybe we have a little extra wiggle in here because of the rain coming and influencing it, first by falling and then by draining through and out and percolating out of the dispersing itself, perhaps, or the ground adjusting and to compensate. However that works out. So that's the last 2 day signal here on top, and looking at the 1 week summit tilt here, there is that last period of 2 days right in there. So that is a little spike of rain. It happens, really, it's the first half of the bump. So really it's this first little chunk right in there is what you're seeing. And you can see that the long-term pattern, if we were to really draw it up, would be still over the last week here from -2 to about +2, about 4 microradians of increase, notwithstanding any rain signal in here as well. So still inflating pretty steadily as shown by the summit tilt here. Looking at the lava depth, we can see a little less because of that same impact of the rain. We have a bunch of false signals appearing right through here. It's when the laser is trying to shoot across that whole caldera distance, those couple miles in. And instead of getting all the way there, it's hitting some raindrops somewhere in between here and there. And then that's what's causing it to think, okay, it's not that far down, it's where the raindrop happens to be. That causes all this noisy signal you see right in there. But you can see the main pattern resumes below that afterwards. So still fairly constantly decreasing. There's this little undulation going through there that we suspect might have something to do with some pistoning effect, or perhaps you can have some tidal influences or some other degassing effects, but it's hard to tie the timing exactly to all those. So still up in the air. Haven't looked into it closely enough to, or heard from the USGS to know any better. But that pattern is still decreasing overall, pretty steady there. If you filter out those cycles that are occurring in a just about daily basis here. So there is that same window of time right through there. You can see that even after the rain is maybe stopped falling, it's still foggy or something happening for a little longer in there. So that's the period of disruption to the signal right there. Now, this is the summit tilt of Kilauea volcano. I thought I'd also throw in here the rift zone tilt, but first let's go and just zoom out from our week lava depth here to a month lava depth. So there's what it looks like for the month. There's a little signal. You can see there was actually had a couple episodes of rising that we noted last week, 1 and 2, 1 being there and 2 being right there. That as more time goes on and we don't see any further signals coming in, it seems more likely to be an adjustment of the crust, kind of tilting or re-leveling, you might call it, following the end of the eruption there, the end of the output of lava at the surface. with the other candidates being lava coming in below the crust and causing some adjustments that way as well. Can't exclude that, but it's much more likely that given the dynamics that it was something adjusting after the eruption was over, leveling itself from where the lava was piling in the southwest to that northern section across the pit there. So that's lava depth, and back to our summit tilt for the month now instead of the week. So here's that little bump right in there. So really right, that area right in there is the signal of the storm. And overall, a very tiny bump on this longer for the last month from -10 to +5 or so, 15 microradians, still on a steady pace coming up. That's significant and notable here. Right. So now the East Rift Zone, because like the summit, there was an unusual bump here as well. It seems like it's slightly longer lasting down there. But zooming into that, this is at Pu'o'o Station. After that initial pulse, we're resuming that trend once again, and so we'd expect this to actually level back out. Oh, that's a bad line there. Let me zoom it out a bit. So here's our trend. You'd expect this to kind of go down, and this eventually to come back down and resume that as well, following that disruption by likely a rain signal. So we could call into question that tilt signal at the rift zone and also illustrate what a rain signal often looks like over there. Right? We know that there's no gas, no other motion, anything happening over there, so that's the most likely explanation here. Timing as well. And finally in here, I just thought I'd throw in the last month Summit SO2. We don't have any new measurements recently here, but the last couple that we've had do still fall in that same range. There was one on Monday before the storm, and prior to that was at 170 tons per day and 104 tons per day, so still very low background-like levels. And this is something that we really won't likely see increase until the next lava comes out once again. But it does kind of show where the range of things are still right now. Okay, so that is the monitoring tilt part of it, and we'll now move to the GPS. And this is what we showed as a summary for the summit of Kilauea here, this upper panel, showing distance north to south across the caldera. And once again, steadily rising line here over the last week, which was not as steady rising, was more flattish the last week before that, right? So it seems to have corrected itself, whether it's through actually physically moving again, and also the data being cleaned a little better perhaps is causing an influence there as well. So interesting to note that on a GPS line, you see that we actually had this decrease that occurs as the eruption begins here, and cause this sagging of the walls together. And we've actually recovered that and exceeded it as well. And of course, it's nothing static, so you can't use the same threshold every single time, but it does give you a relative comparison of how it's moving compared to how far it's moved before. So it's actually moved further than it moved before now, even prior to the eruption coming in here. So that's really the big picture in Kilauea at the summit. Here at the rift zone on Pu'o'o, we are seeing that long-term pattern of the two parts of the rift zone, north and south, coming closer together. That's why the line is getting shorter. Although at the very end, it does get a little noisy. We have seen little bits of noise before, periods like in here, for example. So this is likely something in passing. It's likely a real perturbation there, but it's more likely to do with the actual south flank moving and wiggling those blocks around, as we discussed last week and the week prior, than it actually is magma moving into there right now on its own. And the reason being, we'd see a more cohesive set of signals on tilt and on GPS and gas and all the earthquakes, all those things together. So we're not seeing any of that. We're just seeing a little bit of variation here. And we have seen, looking at the GPS plots, that there is some funny business happening there south of the caldera. So I thought this would be a good chance for us to look at those GPS signals a little bit more closely, as we promised last week. So here is a two-year GPS on Kilauea, and I have these organized by region, and I'll show you guys a map in a little bit here. But to start off with the summit stations, the one that's in the northwest is Uwikahuna, and what I'm most interested in initially here is the up signal. That's this very lower of the three panels. Right, if you haven't seen these plots before, they're divided into components. The top one is east-west. So if the line is going down, it's going to the west. If it's going up, it's to the east. This middle one is north-south. So this one, in case it's going north and west. And the bottom one is up and down, so also moving up. Right, so normally these signals, as far as moving northwest, that's what Uwikahuna does. It moves away from the center. Byron's Ledge northeast moves northeast away from the center. So all that's fairly expected. More interesting is the up and down signal. And you can see here that this was the eruption drop right there. So the 2-week eruption in June. And we've actually been rising pretty steady since then, right? At a fairly similar rate as we had prior to the eruption here. And you can see lasted longer prior to the eruption. In this case, we have not quite risen up as high as we were prior to the eruption. So while the caldera has expanded further away, the top settled in and it hasn't quite built back up to where it was before. And maybe that explains why our earthquake thresholds are a little bit lower right now. We're not having as many earthquakes as before that eruption. So we still have to get to that to believe lava is going to come out imminently. But it seems like we're on our way, already building back up with the ground rising northwest at Uikahuna. We go to the northeast, the ground is rising at Byron's Ledge. And go to the southeast at Crater Rim. The ground is also rising. Pretty steep, you can see, just as steep as it was prior to the eruption there. And we go over to the southwest, or maybe south central at Outlet, and it also is rising up at a pretty good rate there. So that's all around the summit. There are some interesting signals here. This is the last 2 years of data, so we actually have, for example, at Outlet in that southwest area where it connects to that southwest rift connector, that big intrusion that occurred back in August 2021. You can see that on here. And then followed by an eruption in September, which then drops it back down. There's another eruption that occurs in January 2023, and then here's our one in June, right? So we actually have a whole bunch of, we have 3 different eruptions here and an intrusion shown on this plot on the Outlet. It's not quite as clear that the intrusion showed best on this area, but all the other plots also show a similar pattern there, and really in all the different panels. And there's that intrusion era. There is an eruption in September. There is the one. Oh, I'm sorry, that could be the September intrusion, and this wiggle is not something I recall right here, but another eruption here back in January, and then back in June once again here. So interesting stuff across all the signals, but back to the matter at hand here, what's happening now in a volcano, and looking at the up signals, we can then move down to East Rift to those signals as well. So looking at Mauna Ulu to the southeast, and once again I'll focus on these up-down panels. You can see that the most recent data is a little bit of a gap, so it's not quite coming in, but there was no recent change. It's been going down the entire time through the length of this plot the last 2 years. We'll go over to Kananui Ohamo further east that is putting in data and that is showing straight down, nothing like the last couple plots that we've seen. Over to Kamoamoa, that's just up rift of Pu'o'o, and still going down, maybe slightly flattening within that noise range there, but definitely not going up. And Pu'o'o itself, right over here. Similar thing, maybe within the noise, slightly flatter, but really it's still, for the most part, going down. If it is coming up, it's not doing it very fast, and that could also happen from that adjustment of blocks coming around. So in comparison to those, right, I can go a little further. Here's Jacuzzi further east. It's also going down, maybe a little bit of wiggling happening there as well within the noise. And furthest over at the Jonica station, you see this bigger range because the scale here is blown up, it's zoomed in, so you see a bigger range of latest. It doesn't look quite as tight, but really it's still a steady flattish going down here still, not a whole lot of change. So that's the East Rift. Now if we move over to the south flank and look at Ahua is the one closest. There it is coming up at Ahua, and then further over at Puhimau, coming up once again. I'll show you the map in a second because it's going to be hard to follow, I understand. And then by Devil's Throat, you see no more up anymore. And so the map is coming in just a second here, but in recap, down, down, down. Everywhere else you look in all these other plots, everything is going down. Nothing is rising up anymore. So here is our plot in Google Earth, and these are the 4 stations at the summit: Uikahuna, Byron's Ledge, Crater Rim, and Outlet right here. Right? So these are the 4 that I'm showing that main up. And the next 3 that I said also had up were Puhimau, which is this one right here. That's the one also showing up right there. It was this one, Ahua, also showing up. And this one right here. Oh, actually, it was just those 2. Then we come here to Devil's Throat, and that's where you don't see it anymore, not showing up anymore. So really, I could draw a line once again, just like we could when we did this a few weeks ago. that right there is a boundary between what's uplifting, which is in the area over here, and what's not. Down here, it's not uplifting, and all the rift zone, all through here, not uplifting, all the way across. Everything else is not uplifting. If I zoom it out even more, it's really just those ones right there. And all these other signals are telling us that it's not going in the rift zones and either direction here and not adjusting that way, right? But the interesting thing with that is it's really this big wedge that's, we mentioned the southwest rift comes off in this direction, the southeast rift comes off in this direction, so there's this little wedge piece right in here that has to adjust as it's getting pushed by the summit outwards. And as it does that, it can kind of cause some of the blocks down over here to do some funny things and rotate a little bit as well. And that may be what we see over here at the Kalapana Trail station, which is this one over here. Or if we look at this south flank motion, this is the north-south direction here. So actually, this was a place that was going really fast to the south prior to 2018. You can see that what happened here is in late 2021, it actually turned and started going back north again. It's still dropping down, but it's actually moving north and east as well, right? So if this block right here is moving north and east, then it may be getting pushed by something over in this direction. It kind of comes and rotates it out that way. That's just a theory of what might be happening and why you might be seeing funny signals at the rift zone over here that are incoherent, right? No earthquakes, no gas, no tilt, but some funny GPS things going on. So obviously wait further input from the USGS and published research on that, but that's just preliminarily how it looks to me here. Okay, so moving back to the monitoring signals here, I think that hopefully addresses our GPS concerns here, and then we can turn to looking at earthquakes. And let me change our tag up here and look at the recent earthquakes. Starting first on Kilauea. Here's the last week. It's showing 194 events on this map. That's from the USGS. That's picking up all the smaller events that don't show up on the main webpage there. So you notice that the biggest cluster of these is down here in Pahala. There are some earthquakes occurring here at Kilauea Summit. Not a lot by our normal standards. A little trail of them down here, down the Southwest Rift Connector, and a little cluster of them here near the summit. A little bit here in a Southeast Connector, but not as much as we saw last week, right? So you can maybe imagine this pipe piece in here as it when trying to adjust. And the blue one is a deeper earthquake, probably from the feeder source of magma coming in at a deeper level into Kilauea. So that's something you can classify differently here. Otherwise, south flank is still active, you can see, more active in the area just south of the summit, and less active, although still a little bit here further to the east. Really, most of the action is occurring over the last week here down in Pahala. The deep earthquakes that are feeding from here over here and here, perhaps, right? Or perhaps there's a second pathway that comes up. All unknown until we get more information back from all these seismic surveys that have happened over the last couple of years here. So in cross-section, there is a Pahala cluster deeper down. There is a deeper feeder for Kilauea right there. There's a further one offshore. And all the summit and flank stuff in Kilauea is this band further up here. Now I wanted to show this cross-section from the last week because I also find it's useful to look at, as I've shown before, depth against time. And so if we look at, for example, let me scroll down a little bit more and show you the plot of 1 week earthquakes on Kilauea on that map. If you look at this by itself, you'll say, look, this one day, the 16th, had over 60 events. Maybe something was happening with the volcano right then. The second day here of maybe 35 events, that was yesterday. But really what's happening here on the 16th. So when you scroll up to this version of the plot, you can look on the 16th and say, okay, within that window of time, most of the earthquakes were actually down here in Pahala. So that turns out to be a Pahala signal, a little Pahala flurry that occurs. And we have such quiet activity on Kilauea's shallower structure that shines through as the main signal. Right, so I kind of had to go through that. So when we look at this earthquakes and we see this peak, we can know that we can actually filter it out. This is actually not the summit events, not buildup of magma at a shallow level, but rather the deep feeder source. So scrolling down to the last month here, there is that same peak at 60 earthquakes per day. That's the Pahala cluster right there. So we once again filter that out. This one is a more recent one. That's more of the shallow summit stuff. But you see that kind of matches all the other recent peaks we've seen. And in fact, what you mostly take away from this is that the seismicity at the summit has been unsteady and at fairly low levels as well, right? Not constant, with some really low days coming in here as well, less than 10 earthquakes in some of these days. But otherwise coming back to those moderate levels. So this is much different than we saw in a build up to the June eruption. And to put it in perspective, here it is over the last year. Here was a June eruption that occurs right in there. So there's a buildup at over 800 earthquakes per week for several weeks. And we're still down at less than 200 earthquakes per week, even in this resuming inflation, building back up magma underground phase that we have in Kilauea right now. So it seems like it's coming up, but does not seem imminent quite yet, and it might shift gears up fairly quickly depending on how it progresses, but that's getting harder and harder to predict. We'll look at some comparisons of the eruptions here and maybe illustrate why even the patterns that we're holding before are no longer guaranteed. So I just have down here the 1-year SO2 plot because this also shows to us exactly when the gas peaked as the onset of those eruptions. So right there, June, right there was January. Right? So that was a January cluster of elevated seismicity. So we're not even to that over here yet. This might be more reasonable. This was elevated to us at the time even then. So even if we got up to these levels in here, we might say, okay, maybe it's getting close again. But not even that so far. It seems to have been a step back, and it's inflating, but very quietly so. So those are the monitoring signals here on Kilauea. We can keep going on to the latest earthquakes, not just in Kilauea, but island-wide. And here they are on a map. See, there's some events that are these flexure settling earthquakes offshore, like this one that was a 3.0 at 26 miles down that occurred on Tuesday as well. Of these, the newest ones are all on Pahala down here. There is one event on Kilauea, a 0.6, pretty small depth. But I'm going to take this and resort it to largest magnitude first and show you guys there have been 4 magnitude 3s and higher over the last week. And of those, there's some interesting events. So this one right here, 3.2, that occurred also on, Tuesday night, 13 miles north of Ocean View on the flank. This is showing minus 0.7 miles, so it's pretty much on the surface there, and showing a 3.2. So it's not quite clear if that was an adjustment of the ground there. We did have reports coming in during the storm that there were some, quote, brutal winds in upper Ocean View, so you have to wonder if there was any kind of wind affected event, whether it's like some rock fall or something blew over or some rock dragged across the ground across the seismometer. You gotta wonder and look at that a little more closely. But even if it is completely just an adjustment of the ground from the magma building up at the summit in Mauna Loa, then that's not by itself anything of concern. We see these adjustments off the side on the flanks occurring pretty regularly, and that one would be one that by itself would not be of concern. You'd be more concerned if you saw a big one followed by another big one, by another big one, by another big one, and lots of small ones in between and afterwards as well. So that's not the pattern we see, and that's why that's one that's easy to not be as concerned about right now. So other magnitude 3s, we have another one that's 3.2 down here in Pahala. That's well known and understood. There's a second one. Oh, jumped. Looks like it just refreshed here and it took off the 2 older ones off the map for me here. You can see the last one is 2.7, 2.9 also down here in the Pahala zone, so really nothing else to mention right now. Okay, so that is the earthquakes, and now we can turn to our observations. And we'll do that by just first looking at the front webcams. Let me give it a refresh here and get some, hopefully it won't take too long here to, oh, there it is. Get a little hint of a rainbow coming through, so you see there's still some remnant moisture in the air, rain coming down, really, really muggy and humid across a lot of the island here. But you see the crater is actually fairly clear and not much effect from those 3 inches of rain that we saw occurring a couple days ago here. So there it is. I can pan through the views, looking pretty quiet here in an F1 camera. The thermal is showing a few hot spots still on the ground, but nothing really major. And the V1 camera panning around as we saw earlier. There's our west-southwest vent cone that seems to have made this nice broad feature. You can see it now. A little pyramid shape there. That no longer active once again. I don't really see a whole lot of fume from there as well. You do see it around the rest of the crater edge here. Here's the S1. Not the best light to see any detail in there, and I'll just move on to the B1 here, once again showing the sunset over to the west there. So some views of the activity here. It's more interesting for us, I think, to maybe go back through the eruption and look at this time lapse from the KW camera that goes through the entire sequence here. So let's play this for you guys and just relive a little bit what happened during that June 7th to 19th, 2023 eruption. So you saw the lava burst out from multiple points on the crater floor, settles in the southwest vent over here on the right. See it's circulating mostly in the southwest crescent area of the crater floor, while that middle southwest basin still continues to circulate for quite a while. We still see vents emerging from that central area up until the 6th day in or so, until we actually see those shut off and activity focuses over here to the southwest vent, which then increases its output and grows its cone, floods the area with multiple channels and rivers all coming from this area, while you eventually see this western basin area does continue to overturn, but it stops circulating, stops being fed in, it seems, towards the end phases here. The southwest vent seems to pulse a little bit here. You see higher fountains coming up. It finally starts draining into the western basin pits, the southeast pit that occurs as well, and then suddenly, very abruptly, just turns off there. So, and you can see a couple of other points of glow from the last couple of days, and that summarizes that eruption there. So overall, a lot of very similar patterns that we've seen to other eruptions. We've seen the same pattern of it emerging in multiple places initially, flooding the whole crater floor very quickly. That occurred here as well. We did have those videos we shared last week with extra detail of the gas coming up and through and the floods and breaking the crust and a little bit more of the sequence, which is all thanks to the USGS's new live cameras they have up there and are streaming continuously. That's really awesome. Great step forward here. So we also see it then localized to fewer vents. These seem to be towards the south and the southwest. We early on identified the southwest vent because of its higher elevation as a likely one to persist. That turned out to be the case. And as time goes on, you see most of these other vents coming outside the crater edge here and coming through the crater floor there, seeming to peter out. You see circulation in a central west basin slightly longer there, but activity is all shifting to the southwest vent, right over there. And then by this later time right in here, by these second couple nights, you see hardly any activity in the western basin apart from lava pouring in there from the southwest vent, coming across the southwest crater and then refilling these lower depression areas, basins over here and down in here as well. So a lot of very similar features. What was really different was how it just at the very end here just shut itself off. Right, that's a real major difference. Everything else is pretty similar, but that's our visual recap of the whole eruption on a K1 camera. Thanks to Dan, we actually have a couple other passes at this. One is a daylight only view. So here it is, daylight only view. Same progression, so I won't say the same things. What I'll try to point out is, I pause it in some areas in here, is you can really see this in the daytime, how this terracing occurs and these different little levees and edges of the perch ponds that seem to be building and different channels that sweep down across the landscape. So something to keep your eye on. Maybe I'll zoom it into there as I'll play this forward again. Really see those different levels of lava as filling and then draining. And especially towards the end, you see those seem to really become prominent. They're more visible or less visible depending on the time of the day. You see the kind of perch pond area built up there, and here it is all drained. And at the very end, I'm not sure if you could see it very well there, but at the very end, you actually see the edge of the perched area here start to sag back in towards the middle here. Let's see if I can show that to you guys. There it is, right there at the end. Try it again. Pull it back. Let me zoom it in. You guys can see it right there, that sagging movement right there at the very end. So interesting, we saw a similar kind of thing at the end of the last eruption that occurred back in this part of the crater in January to March earlier this year. Similar pattern over here in the southwest. And let's turn now to the night-only view from that same camera, and here it is. I'm playing it extra fast so you can get this overall picture of this overall flooded crater floor, then focusing to the southwest, an eruption really going well from the southwest vent, and then a really quick sudden shut off that you saw right there. So one more time through, flooded crater floor, withdrawing. Note the central western basin there, it's circulating still as well. Then it shuts off. High fountains from the southwest, sweeping across, quick shut off there. What you got, Dane?
Oh, sorry, I didn't realize I was unmuted. I unmuted, I guess, earlier when you were trying to ask a question. I didn't mute since then.
All right. So yeah, thanks for the time lapses there. That's our visual recap of the eruption there. I don't think we can need to go into a whole lot more detail than that right now. There might be a case here and there where we look at some new feature in the future and we come back and refer to this, but really that's the overall pattern that we see here.
I got a question for you though, right while we're here though. The deflation afterwards, right? That sinking. Is that gas escaping? Since we know this was a super gas rich with pockets of gas that escaped. Was that something along those lines, or this just like the bohoihoi, like it degasses as it and creates that void space, and it the weight of itself collapses under itself essentially, or what do you think? What's going on with that?
There's a little bit of the same things, but I think of those options, the second one is what I'd pick, Rick. 'Cause I mean, I think that what we talked about last week was the bigger bubbles of gas coming out more to start. So it's almost like when you're clearing your water line or your hose, like you might get those bigger bubbles at the start. You might have some extra gassy stuff there, but the regular stuff is still pretty gassy, right? So it's still pretty fluffy and frothy, and so we also saw that the lava was really piling up in that southwest part of the crater to the point where it was pouring over into the western basin and pouring over into the western basin southeast pit area too. So it was definitely frothy enough to kind of sweep over and pour over those things. And basically, maybe once that wave goes across, you have less volume in there. Then it also is just degassing just straight up and cooling and settling back down there as well. So I would say more so the second option, the gas entrained in the lava itself rather than any giant big bubbles. So the lava obviously is very, very gassy all the time, and that's a good example of how it actually can settle down. Just like almost like if you're trying to make a soup or something, boiling a soup, and it's just getting really frothy, and you just turn the heat down, it can come down a good amount just from the bubble levels, like not being quite as bubbly and boily. That's my take anyways.
Yeah, a lot of gas on this one. Just it's hard to envision, like conceptually, just how much gas was trapped in this eruption and got brought to the surface. That's the weird thing to me still, is just how much of the volume, that pocket that they're talking about.
Yeah, especially at the start. Yeah, I mean, and it's hard. We talked about this last week, how it might be, up to like 5 million cubic meters area, but then that's the combined net difference, right? But some of that might have also been lava coming up and through. So the lava was bulging the crater floor below and gas, and then the gas pops it out. That kind of sags it. But then the lava also goes from below the crust to above the crust, so it can move and actually erupt without changing the overall depth from above, right? It just moves from below to above. So it can get a little weird in there too, for sure. But I still think more at the beginning of the eruption than towards the end is where you really have that extra gas output.
Right. Under pressure, the gas would be more compacted. Yeah. It just the unit of measurement maybe what's throwing me off. Like it's a volume. Yeah.
Yeah.
Isn't that what it was?
Exactly. Yeah. Exactly. Yeah. Yeah.
Right. And maybe volume, that changes depending on pressure, huh?
Absolutely, yeah. Especially the gas.
So I'm like, at what point are you saying that? Like, is this as it comes out we're taking this, or underground, or like it's just weird to me. It's just hard to conceptualize like that whole thing.
Yeah, that's why it's so important to note that they actually took that scan. I want to say it was like 4 hours into the eruption. So as it was coming out, to answer your question exactly.
Okay. Okay,
Yeah,
as
so
it's
that's-
coming out. All right.
That was very, very rare to catch that exactly at that moment, but they did. So it's awesome.
Right. Yeah, awesome to catch. It's just like, wait, what? That's so weird. Like, okay, I need to think about this. All right, thank you.
Yeah. A lot of little details to keep track of for sure. And yeah, that's once again my take on that. We have a little more to show you guys here as far as we've shown you these thermal panels before of the different scans USGS similarly took from the helicopter overflights there and their thermal scans. What I thought what we could do today is just play you a little animation that actually, now that we've gone through visually what that looks like, looking from the air from the map view, that same kind of pattern of these 5 different frames here, June 7th, 8th, 12th, 16th, 22nd, and then looping back around, right? So really see how it floods the entire crater floor. Note that there are all these northern vents early on here, that they shut off first before anything else, right? And that is actually not too far from where you have this final ooze up that occurs on the 22nd, is it? Yeah, right there. Which, by the way, is just follows that first tilt adjust or lava depth adjustment that we saw on a lava lake further to the west. So it could be that thing actually adjusted, caused lava to squirt out the other side, adjusted over here, and then that's what you saw as an ooze up potentially. Because we saw that those adjustments were both in the order of about 1 meter each. And towards the end, as you can tell, all the lava is piling up here in the southwest, right through there. This area down in here, that's the down drop block, so it's kind of perched up and not really affecting the seesaw so much. It's more the stuff that's piling up right in here, this little swath, right? That's probably weighing this thing down and tipping the seesaw down towards itself. And so when the lava stops coming out, it's still liquid underneath that entire crust, and it can maybe adjust itself, pop up, so you see it actually raise on this side, and possibly, I would guess in that case, it might sag a little bit on this side over here. And without another measurement of depth anywhere else on the crater floor, it's really just a guess. So really be curious to know what other depth changes have occurred anywhere else on the floor here. That's one interpretation that with the little data we have does make sense. So there's that animation showing that the thermal progression. And what I thought we would do is once again revisit this map. So this is what we saw last week. This is showing the final volume of 9.1 million cubic meters. And the extent is really only 20 feet of filling, 6 meters total, right? Because of that larger area that it covered, 368 acres, 149 hectares there. But the key thing is that this is data from, let me put it back up, from the 12th, right? We know the eruption went all the way till the 19th. So we have a whole week missing here. We haven't had a map come out since then. However, since it has already been more than a month, I did want to try to get some statistics put together for you guys here, as much as we can so far. And presuming another map does come out with revised numbers beyond this, then we can revise it once again here. But otherwise, what we can do is take this first 5 days of eruption as representative, and most of the action maybe occurs in this first 5 days anyways. So let's take these numbers and plot them up against the graphs that we've done in the past. So we have on here 4 different eruptions. We have the 2020 to 2021, which is this light blue, that in total added up to 41.2 million cubic meters. Right? I'm only showing the first 5 months or so of eruption here in this plot to start. So the second eruption was the one that was September 2021 that ended in December 2022. That went over a year. That's this more purplish one that comes off the map and keeps going off to the right here. On this map, it gets up to around 50 or so, but ultimately it ends up, what is it up here? 110, a zoomed out version right there. So that's the second eruption that comes. The third one is this red one right here, the one that occurred in January this year. That one, you see it comes up pretty fast as well, but it actually then more quickly goes off and ends up at 16.5 total million cubic meters. The one we have now is only 9.1, so it's really the one in green right in here. I gotta zoom it way in, and I only have this one data point right here. I'm assuming that for this particular plot that didn't change by the second one. This likely goes up. It probably goes up a little bit, like some amount based on the final value there, but our best guess is basically this, and you can see it came up at a similar fast rate and then just stopped. And that's the thing that made it different. It just stopped right there. So let's move back out to this scale. There you see it right there, the 9.1 with very much shorter length compared to the 16.5 with a little longer length compared to the 41.2 with an even longer length. And I gotta go to the zoomed out version where it gets all the way to 110 up here, where the one lasts more than a year. So in this case, there is our 9.1 right to there, very small, it's just a blip on the pattern that we see. So initially same pattern, but then really just completely truncated and aborted in some ways right there at the beginning. So what I thought I would do is try to compare the eruptions in some way here, and this is a little bit not intuitive, so I'm trying to talk through it here. So what I've done here is put up here in 4 bars December to May, that first eruption of 2020, 2021, 2021 and 2022, the start of 2023, and then last month right over here, right? And so starting off back in the first eruption back in there, that eruption in red is showing how long the eruption lasts, 153 days. So then the next one was longest, 447, and then the third one was 61, and the very last one we had was only 12. Right? That's the red bar. The yellow bar is the volume, how much lava it actually put out. So 41.2 million cubic meters. There's 112, there's a 16, and there's our 9. I have this on a log scale so you actually can see it easier here, just in case that doesn't quite look to scale to you guys. And the last one here that I put in is a green, at least in this first set of bars, is a green one, which is the actual average effusion rate in cubic meters per second. So the entire volume of lava divided by entire length of time it took to come out gives you a rate. In this case, 3.12 cubic meters per second. So you can see, if I just jump ahead a little bit, that the eruption rates are pretty similar for eruption number 1, number 2, and number 3, all very, very similar at around 3 cubic meters per second right there. And it's the most recent one that actually ended up at 8.8, almost 9, almost 3 times that amount, 2 to 3 times that rate. And likely because it didn't have that long, drawn out, petering out stage where it's putting out a much lower volume for a lot longer to kind of bring the average down or so. So that's one thing you can note, is that the average rate does end up higher because you basically truncate it there. So for these other plots, you can see the blue is showing the repose. So how many days in between the end of this eruption and the start of this eruption? Right? In this case, 129 days. In this case, it was 16 days. And the last one, it was 92 days. And so what you can see is really the first one doesn't really count. And before this was 2018, where it's refilling the collapse zone. So touching that here in a minute. But you can see that when you have this long repose, you had a long eruption, putting out a lot of lava, right? So one way to try to quantify that is by taking the volume and dividing it by the repose time, and that gives you not exactly a recharge rate, but like call it a proxy of that, right? So you're getting at a value of 10 cubic meters per second here for that first one. I should say the second one, the first follow-up. The second one coming in at around 12, so pretty similar to those two. The very last one we have here is down at 1, at 1.14, right? That's the zoomed in version there. And really, the way to understand this is we waited a long time for this eruption to come, relatively speaking, and we got very few days of eruption out of it, compared to what we saw previous to that, where we had every time the eruption comes in longer than the repose, and ultimately averages out to that same value. Right? So all of this is basically caused by how the eruption got truncated towards the end. It's very similar otherwise in how it starts up and goes, but it is breaking a pattern all of a sudden here, right? Where we actually could before, if it had done the same thing, you might say, look, the pattern is pretty clear and consistent. We know what to expect exactly. We can predict the same pattern is gonna likely play out again. But we're already seeing signs here that something is a little bit different, right? It's in a longer amount of time, not able to get quite as much lava out, right? So why might that actually be? Maybe there's less magma coming in. Maybe it's slowed down in some ways, or you've caught up, so you relieve the excess pressure. That's one possibility. If that's the case, you'd expect it to actually slow down a little bit from what it's done in the last couple of years, right? That's one possibility. Who knows? Another might be that this is not the only area that's filling with magma. Maybe, as we saw through our GPS and through other intrusions in recent years, magma is actually moving elsewhere. I'm not counting any intrusions in this calculation here. I'm not counting any of the actual spreading of the south flank and widening of the summit chambers, accounting for volume for that as well. So this is very, very rough. It could be the magma is going those places instead, rather than going all out of the ground through the eruption site there, right? So that could be some variations. In any case, the bottom line, all I'm comfortable really saying is a pattern seems to be different here, and it's likely because of that very end phase being so abrupt and cut off there, right? But it also makes me more hesitant to say, well, the pattern has been this and this so far, and so likely it continues that way because we can see it's not continuing that way since this last time, and now it makes it maybe even harder to predict and anticipate what might happen in the future. Prediction is always a fool's errand anyways with these volcanoes, right? We like to kind of just put our thoughts out and just kind of talk through possibilities for the purpose of education here, but it's always been guesswork, and now it's perhaps even more so that case. And so that's the whole point of this, and otherwise I wouldn't take any of these numbers as official, and it's just my back of the envelope calculation for you guys here to just try to put some angle and slice on this thing here. To pull it back a little bit, we can go back to, there was this paper by Michael Poland, Elska Dalfsen, Marco Bagnardi, and Ingrid Johansson. This is back from 2019. Post-collapse gravity increase at the summit of Kilauea volcano, Hawaii. And I'll just show you guys a key figure here, which we've shown you guys before. Pre-2018 collapse, we had that summit chamber feeding the summit lava lake up in here. There was immediate collapse with the magma essentially withdrawn and lots of void space in the collapse area up through there. Right? Between November 2018 and March 2019, there was no lava at the surface, and there was in fact water collecting at the surface. But in that same time, there was measurements of gravity showing an increase in gravity, even without any increase in tilt or GPS or anything like that. So that was a period of time when magma was known to be filling these void areas, but hadn't quite locked in the pressure to start bulging it outwards yet. That occurred in March 2019. So that's when we saw both the gravity increase and inflation signals coming in the volcano. And from that point on is when we had these now 4 summit eruptions. So I bring this up just to show when we talk about potentially other areas magma could go in a summit, we're working with this really broken up canvas, really, right? This is our starting point is not from scratch, the perfectly clean system or so. Excuse me. So another
when it's
consideration there. Go ahead.
What is the betting line then for the over under date? That's the. Is it months?
I just finished saying it's really way harder to predict.
I know.
I don't know.
I know. They still make betting lines even when it's like, you know, ridiculously abstract. So it's like, all right, 3 months over under. Where are you guys at?
Yeah, you know, 3 months might be a reasonable thing. You know, I mean, and I would just say that variance might be a lot bigger in this one than the other ones, right? You might typically say, okay, right. Well, we expect the eruption to come in, let's say, you know, 2 months, give or take 1 month. So what am I talking about? This might be 3 months, give or take 2.5 months. You know, who knows?
Right.
Exactly.
I mean, the last one was a pretty wild one too, because we made it early, then it kept doing the intrusions and then backing off, and intrusion, back off. So that one was probably over by like 3 months itself from the line.
It broke the pattern.
Like
yeah, absolutely.
Yep, broke the pattern.
Yeah, and so yeah, just as far as why that might be happening, I just thought I'd bring this up again and put it up on the screen one more time.
Right.
And that's really our Kilauea update, where Kilauea sits right now. It's once again a wait and see. I do have a little Mauna Loa to talk about before we wrap it up here, Dane. Unless you want to throw anything on Kilauea before we do that.
I think that's good.
All right. So let's switch over to our Mauna Loa monitoring then. And really quickly here, I just show you the Mauna Loa signals. All right, so that's the tilt signal on Mauna Loa today for the last month. And we're looking at this blue line, which is the radial component towards the magma chamber. And it's showing this overall pattern of increasing tilt, as we've seen in all the recent months since the eruption. Occasionally it does have a little wiggle down like this, right, that we know can occur from potentially magma movement underground adjustments, that kind of thing. But we have one right here at the very right end, which very suspiciously corresponds to the same time range as we saw the signals of the storm both on Kilauea Summit and on Kilauea's East Rift. So it does seem like we do have also temporary, short-term, small kind effects of the storm here on Mauna Loa signal as well. But the overall pattern is still like Kilauea. We're down here at like -1 to +2, 3 microradians of inflation, which on Mauna Loa scale is a lot to be seen at the summit, showing that recharge is still strong and ongoing there at the volcano. Earthquake rates still down a lot. These are earthquakes per day. The highest number is 9. So these are all just really just blown up. Lots of, looks like it's changing a lot, but it's all very, very low within 10. And the better way to look at that is looking at the whole last year of earthquakes. Here is an eruption that occurs, earthquakes that led to the eruption and the ones that build up to it the months ahead of time in Mauna Loa. And here we are still within this very low post-eruption background level of earthquakes. There's a last year. Here's the last 5 years, just showing once again how we're lower still at any point than anywhere in the last 5 years. So it really is really quiet there, right? And here are the earthquakes at the summit. Very dispersed and small. You can probably barely see anything on the screen here. There it is in cross-section. And you see, looks like a little bit of the deep feeder source down there with these deeper earthquakes, and then shallower stuff above. So both of those occurring. That's interesting to note those deep earthquakes, the blue ones down here. The feeder zone of Mauna Loa showing that its magma supply system is likely still very healthy and magma likely still coming in through there. But otherwise not much to really highlight, right? In more detail, looking at depth and time, there is the band of deep earthquakes. Seems like they begin here at the beginning of July with a couple of big events and a lot of smaller ones kind of following up afterwards, right? So it seems to have reactivated with some pulse starting in then and working its way up and through right here. So that is the most of what we have from Mauna Loa. However, I did want to point out, let me come back to my Google Earth here, and I don't quite have things set up on Mauna Loa, but there are GPS stations on Mauna Loa as well. A lot of them are not working, but one of the ones that is this one, Oahu Hanalei. There it is. And that's the one that, if I can come back to here, zoom in into it, right? You can see that there is the eruption signal. This is the east, north, up once again, right? So this thing is moving to the west and to the north and up right now. And what I was really pointing out earlier is the scale here. We're looking at 0.10, 0.15, so 10 centimeters, 15 centimeters is 5 centimeters distance between these two lines. You can see that post-eruption, we're down here at the bottom of this one. And within the last few months here, actually hit the upper line, right? So that's 5 centimeters, that's 2 inches of vertical uplift at this site right here near the summit, 12,000 feet, not right on a summit caldera, but within that summit range right there. And we're seeing that uplift occurring. So, and once again, as I mentioned, it seemed like it started off a little bit faster, maybe a second slower phase, and then here there's some extra noise, but if anything, I would average that out to a little bit more flat there. So just a little bit more of an analysis and peek into how this recharge occurs and how it actually swells the mountain and how it might actually manifest, right? So that's what we can see. I go back here to the Google Earth. I want to see a lot of these don't work. That one does work. So a little bit lower down on the flank, you can see we see the drop down with eruption, but we don't see any increase since then. It's basically stayed flat. That's the station at SLPC right over here, right? So like once again, you can draw a line between what is inflating and what isn't between these two stations. Unfortunately, these two over here are not working, and then further out, everything further away is outside of the range once again as well. So that's what we can do for sure, is just this one line right in here. Somewhere in there is the boundary between what's inflating, what's not inflating in Mauna Loa. So a little extra analysis there since it's been a little while for us looking at Mauna Loa. So that covers Mauna Loa as well. We do have a couple of final items here, starting with the Volcano Watch this week. Let's bring that up for you guys. Here it is, Volcano Watch. Hale Maunaloa's 1967 to 68 eruption. Another crater filler. This is an interesting take because it makes a comparison between a 2018 eruption and a 1965 eruption, actually. Right? So it's actually saying 2018 paired with 2022 and to now, right? The kind of collapse phase and the refilling phase from 2020 to 2023 is similar to the 65 collapse phase to the 67, 68 refilling. And that's what they're basically going with here. Key differences, of course, were that in 65, the eruption occurred around Makapui area in the East Rift Zone. So it was like that middle East Rift Zone. It didn't get quite down as far as Leilani, for example. So there wasn't quite as much lava draining out, and the collapse wasn't as big. And that 2018 event was a lot lower, closer to sea level. Major drain out, major eruption, major collapse. But what they note is that there were similar timeframes of quiet, non-eruptive periods following both of those eruptions, and about 2 years after each eruption, the summit magma reservoir recharged and eruptions occurred. HVO staff wrote that the 67-68 eruption was preceded by only about, quote, 1 hour of gradually increasing harmonic tremor. The eruption has been expected for over a year. So that's a very similar pattern to what we saw recently here, where we saw increasing earthquakes. The GPS was showing all this strain on a volcano, but it wasn't actually erupting, and when it did so, it ramped up and did it pretty quickly. So that's definitely similar as well here. Here's a 67 eruption, crater floor, and a further up view, like for the later phases, where it's building that perch pond within it as well there too. Maybe you can see that if I zoom it in a little easier. Perch pond area there, and similar kind of view. It's hard to tell the size of this, right? But that whole perch pond would be right in here. This is the entire crater floor of Halemaumau. An initial outburst, flooding the whole crater floor once again. Similar kind of stuff. And then they basically say that apart from that, the instrumentation is much better nowadays. And so there are some things that are harder to compare there. But otherwise, they did note that the filling process of Halemaumau, that in 67 went on for 9 to 10 months or so, and filled up 370 feet of lava in a crater, 113 meters. So obviously, since the 2018 collapse here, we've had 4 different eruptions between 2 weeks long and over a year long. We filled it a total of 1,270 feet, or 387 meters in total. So that's the comparison there, and some similar views of that initial phase, 2018. I'm sorry, 2023, June 2023, flooding the entire caldera floor. Pretty similar to this picture right here. And then this perch pond view here from later in 67, with similar view here from September 2020. So that's the foundation here. They do have a one last note here at the end. They do note that Tom Wright and Fred Klein in their publication noted that in the 1960s and 70s, the HVO, quote, along with improved instrumentation and methods came increased challenges to the HVO staff as eruption frequency underwent a dramatic increase. So the other thing that's similar here is dramatic increase in eruption frequency. We've had 4 summit eruptions in the last 3 years here, so that's definitely an increase here. And so the challenge will come to HVO and USGS once again, because they are increasing all their monitoring and their research. They're increasing their staffing, all kinds of funding coming in, including the Supplemental Appropriations for Disaster Relief Act 2019. But the staff are staying busy, and also because we have all this new instrumentation, there's a lot more science coming out of it now, because there's so much more data that we have from before. So we'll just keep riding a wave here. We'll see if the eruptions continue to be dramatically more frequent, and if that's the case, you might expect them to be shorter as well, as we're seeing the pattern a little bit occurring now. So that's still something to inform our outlook moving forward here, what to expect when you really can't predict anything. So that is the Volcano Watch for this week, comparing 67-68 to our 2020 to 2023 eruptions. And we can end here with an update on our community events, of which we'll just feature the National Park today in our community corner. The tropical storm that came through did cause some disruption. The park did close. They canceled their After Dark in the park. I should say postponed it, in fact. And so we have here today on July 20th, scroll forward, the rescheduling of Don Swanson's talk about HVO and Uikahuna is now Tuesday, August 22nd at 7 p.m. And still on schedule for this Saturday at the Kahuku unit over on Mauna Loa Southwest Rift. If you're going to go and explore the 1867 fissures and eruption sites and all the cool stuff that's out there, lava trees, lava channels, all kinds of stuff out there. That is Saturday, July 22nd, 10 a.m. to 3 p.m., as well as, of course, all the participating halal cultural practitioners. They have all kinds of stuff that you can do, live music, including all these artist lists on here, which I won't try to read through. But that is this Saturday, July 22nd, 10 a.m. to 3 p.m. There is an After Dark program next Tuesday, the 25th at 7 p.m. about Papahana Mokuakea. And that's the largest protected conservation area on Earth. That's all the outer Hawaiian Islands and the ocean area around them. Monk seals, sea turtles, seabirds, lots of sharks, all kinds of cool stuff out there. So that will probably be an interesting one. And then there is, once again, another Uikahuna program rescheduled. This is a Saturday walk with a park ranger. It's now Saturday, August 12th, 10:30 a.m. to 11:30 a.m. In front of the Jagger Museum that actually walks out around Uikahuna and covers a lot of that changing landscape and history of the area on site there. That's all I'll go through here. All the typical things are still going on. Explore Kahuku, walk into the past with Dr. Thomas A. Jagger, with our supporter of the program here, Dick Hirschberger. So definitely check that out if you haven't yet. And stewardship and other ranger walks still ongoing here. So that'll kind of wrap us up here for our community events through July, Dane. And with that said, I'll pass it over to you.
All right, I need to test my microphone. Apparently, it was crazy loud.
It sounds okay now?
It's still pretty loud. All right, I'll try and go ahead and set it up like this and run like this. Hopefully, this isn't too loud. All right, so we did have some supporters come through. We want to thank everybody that tuned in today. We rely on viewers like you to help get the information out there. Likes, subscriptions, shares, all that stuff really does help with all the algorithms and things along those lines. We don't pay for advertising, so word of mouth is all we got, and appreciate that. Also had a few donations come through. Want to thank those. The first one was from Hal, a $4.99 super chat, said, "Welcome home, Philip." Christy came through with a $20 super chat, said thank you for the updates. And Skyjet Ed came through with a $20 super chat, said welcome home, Phil, aloha. Appreciate all the support there, some longtime supporters in there. And, we appreciate everybody that tuned in today. We are now done with the Bye-Bye grant. That was the County of Hawaii's support of this program. We appreciated that run that we had with them. And yeah, now we're going to be trying some new things, so expect some changes coming up in the future.
Yeah, pretty quick here. We'll make some announcements within the next couple of weeks.
Pretty quick. Yeah, sooner than later. All right, well, we did have one question. Let's go ahead and do that if you like. John asked, do you think Mauna Loa will erupt again sooner than 38 years?
Yes.
So his over-under is 38 years. You're taking the under on that one?
Yes.
I'd take the under on that one. I'd probably even give odds. I'd probably even get odds on it, type of thing, 3-1 or something. Because that's pretty wild.
Not be flippant about it. I mean, I think what you see is like the activation of the Pahala deep source, the activation of the deep earthquakes under Mauna Loa, continued filling of the summit, and seeming resumption of the flow into the mountain there after those 38 years, combined with the pattern that we see historically of typically you have it coming into the summit, then going down the rift, and then going to the summit again. Like, it seems like it doesn't turn off for that long, and really it's an abnormality. The 38 years is an abnormality for the whole rest of the sequence there. So I would
Right.
say it could happen
Good
in as little as 2 years, potentially, likely more.
Mhm.
But I'm much more in the, if you gave me an over-under of 5 years, I'd have a much harder time with it.
Right. I might go over on 5.
Yeah.
Yeah, it's hard. But yeah, 38 years I'm taking under, and I'll lay you 3-1 on it type of thing. Because it's just it's such an anomaly, that 38-year gap, and it's hard to bet on it again happening immediately.
Yeah, and it's
At least to me.
real question whether that was a real change that occurred that's like long term, that we're still in that long term change where it's going to be another long time, or did it flip back? And I mean, the only thing I really have to go on is we have this major change of earthquakes in Pahala that was followed by this most recent eruption in Mauna Loa. So not like imminently, but within 10 years or so, right? So I mean, I feel like we're in a new era. Personally.
Possibly. We will know more after the next eruption for sure, whenever that is.
Yeah, absolutely.
All right. Well, I think that does it for me today. Appreciate everybody interactive in the chat. And we will be back next week, 5 p.m. is Thursdays or standard time, unless something happens. We don't really expect it, but you never know. We'll see you next week. And yeah, I think that does it for me, Phil.
Well, thanks, Dane. Yeah, I don't have anything else to add.
Welcome back.
Thank you guys for sticking with it, and thank you for all the
Shout out
work you've been doing this whole last month. Go ahead.
Oh yeah! Shout out to Two Pineapples. They're getting another grandbaby as we speak, or tonight or tomorrow. They're on the mainland right now, so shout out to those guys.
Yeah, shout out to you guys. Yeah, for sure. Appreciate you guys contributing as well, and yeah, all you guys who kept this going while I was not sitting in the same chair right here. So appreciate you guys. Thanks once again, everybody, and we'll see you next week from HawaiiTracker.com. He's Dane DuPont. I'm Philip Ong. Aloha, everyone. My mouse.